Welcome to Training Tuesday, everyone. Thanks for joining our webinar today. My name is Heidi Reese, and I am the Training Program Manager here at Dayton Superior. I want to go over a couple of items before we get started. Same old, but I just want to remind you that you have joined muted. But that doesn't mean that you can't talk and chat with me or ask any questions throughout using the Q&A functionality as well as the chat functionality and Zoom. And at the end, we'll have a mini question answer session that you can get your answers from Chuck if he is feeling good enough today to not make anything up. No, I'm just kidding. In addition, I wanted to remind you that all of these webinars are recorded and put out on Dayton Superior's YouTube channel, as well as DaytonSuperior.com. And you can just search on Training Tuesday within DaytonSuperior.com. You'll find the latest and greatest of the 4 that we've done, as well as all the rest by product, by subject, you name it. And if there's anything that you want to hear in the upcoming weeks, give Chuck and I an email or put it in the chat today, and you can email us at training@daytonsuperior.com. Okay. So like typical, I want to remind you that this presentation is intended for training purposes only. So what that means is that anything that we're going to talk about within here, you need to go out to DaytonSuperior.com and get any technical specifications or TDS documents, safety data sheets, anything that's available on DaytonSuperior.com for the product. Read over those prior to using. And like always, this presentation is protected by U.S. and international copyright. So Dayton Superior is the leading provider of engineered solutions. So what does that mean? We always talk about the products. We have a wide range of accessories, chemicals, forming, but in addition, we have a lot of engineering, biggest staff in the group, in our industry, as well as training. So these are little mini training sessions to get you interested, hopefully, and refresher courses, or if you've never even heard about it, you can get a little snippet, and then you can contact Chuck and myself at training@daytonsuperior.com and ask for more. So this is an introductory. If you need more, contact us and we'll make it happen for you is what I'm getting at. So today we're going to be talking about some precast lifting applications. And to talk to us about it is none other than Mr. Chuck Hoke. With 49 years of experience in concrete construction, he is a prominent figure in the industry. You're prominent. Did you know that?
No.
Can I make you a sash that says Mr. Chuck is prominent and you can stand like the Statue of Liberty? No? Okay. He's been 20 years dealing with accessories, forming, and chemical products as a dealer. And then 29 of those years has been in Dayton Superior land. So his diverse roles that include product management, a lot with splicing machines, business and civil engineering degree, he's got it all covered here. And he is uniquely qualified as our subject matter expert. And I'm going to shush and let him get on with it. So Mr. Chuck.
Thank you, Heidi.
Sure.
You,
I'm what?
Yeah,
that's all you got.
yeah, that's all I got. I'm not even gonna go there. So, as Heidi alluded to, we're gonna talk today about the overview of precast lifting applications. We're gonna talk a little bit about the lifting inserts themselves and where they are typically used within what types of projects. So, here we have architectural precast. We're going to talk a little bit how the precast industry segregates itself. You have architectural guys that do building facades and building panel. Typically you see a lot of these precast tilt projects going up, and those are the panels that are actually cast in an architectural plant because they have the longer beds in their facility, can actually accommodate them. Panels will then get trucked out to the job site and erected. We got the heavy civil precast projects. Now, these guys are a little bit different. These guys are making everything and anything that needs to be assembled on the project. So, you've got box culverts, you got basically erosion control mats, etc. But you see a lot of these, and they'll do a lot of bridge work also, especially Uh, in the smaller bridges where you're typically only going over a creek or whatever, so you only may have a 70-foot span or 60-foot span. Perfect application for this type of material. So these guys here, heavy civil precast guys, typically make up probably, I would say, probably close to half of the people in the industry. And then we have our utility precasters. The utility precasters also make box culverts. Typically, they're a little bit smaller, but their mainstay is to do things like concrete pipe, uh, wheel stops. You're talking they even go as large as doing signal buildings and so forth. And actually, I was up at a precaster last week, and the guy was shipping out 3 restrooms on 3 different trucks that were actually assembled in the facility in his precast shop, being sent to the site. The plumber hooks up all the utensils, and they're good, ready to start operation. Very slick operation. You are seeing a lot of projects now looking at precast being a premier way to manufacture these products, because primarily they do it in a controlled environment. And when we talk about what we're looking at for a controlled environment, they have a lot of different agencies looking over their shoulders, such as ANSI, ACI, OSHA, obviously. They actually have to rely heavily on the safety factors for lifting and for uh, other component pieces being used. And primarily reason being is because with precast, different from any of the other subjects that we talk about, typically is one where the insert or the anchor is going to be used, basically finish using it, set it to the side, then come back later on and reattach to it at a later time to reassemble it. So you've got it basically a assemble, rest, periods
I
with
like to
this.
do that in my life
Yeah, huh?
because I don't want to be carried to a bridge.
Yeah, I know. So, so basically what you're going to be doing is you're going to be looking at determining how to the load of the insert, what's going to be put on it. You want to basically look at the concrete element itself. Some of the things that you need to also take into consideration, besides the weight of the concrete, is the adhesion to the form surface. If you're doing wood or steel, that adhesion is a little bit different and can escalate relatively quick, especially with a steel form. I was surprised when I actually learned this way back when, how much steel actually adheres concrete to it. So, and then obviously one of the first things you're going to be looking at, what's the PSI of the concrete when you have your first lift? Weaker concrete, going to mean weaker insert. The inserts play off of the strength of the concrete, with embedment, et cetera. So if the concrete isn't up to strength, you are going to have a little bit weaker conditions prevail. You're also going to be looking at insert location, edge conditions, whether it be on a thin wall, the rigging, direction of pull, which is going to be extremely important when you find out when I'm talking to you here about this here in a couple more slides, and the number of inserts utilized. You're going to be talking about flexural strength, especially with the taller panels when guys try to pick them up from the end of the tractor trailer, pick them up, and then take them right from the end of the truck and stand them right into place. Those numbers all need to be taken into considerations when you're placing an insert and looking at where you are going to position the insert within the panel. You also have to be worried about dynamic loads. Now, I put this slide in here just to say, okay, yeah, these were the original inserts for lifting and placing concrete. They are typically used now for predominantly attaching small workable items, basically uh, one-time uses, that sort of thing. They aren't being used as readily as they used to be. So, but just to know that they are out there. You also are looking at different types of lifting conditions here. A lot of municipalities still like this system because one, it's very cheap to own. The inserts are very well priced. And you can actually, you don't have to have a lot of cover material over the recess void. As a matter of fact, most of these inserts have no recess voids. You typically will use the coil bolt that you're going to use to lift it with as your recess void. So with that being said, this becomes very economical for like I said, municipalities, like for traffic signals and vaults that are buried in the ground, that they can actually use a slotted coil rod to fill the insert in after they get before they backfill. And then when they have to ever get into it, they come back in, they shovel all the dirt off, they find that slotted coil rod, spin it out, drop a new coil bolt in on top of the lifting hardware, and they're ready to go again. Now, ferrule inserts. Uh, Ferrule inserts, great product, NC threaded. And any of you that know, anybody here that knows me, well, I will tell you to my grave, do not lift with an NC thread.
You will.
Do not. Because what happens is with an NC thread, it is a machine thread, similar to what you get like with an A325 bolt from a local hardware store. And it's not the thread or the bolt itself, but it's actually the thread makeup, because the thread makeup has a very thin pitch to it. And what happens is you can actually shear that thread off the bolt while you're lifting it. So typically you're going to use a ferrule insert for permanent attachments where you're going to basically screw it in once, one and done, leave it alone. So that's why we never use this for lifting, because it's not very good in dynamic loading, etc. So most inserts here, like any of the coil type inserts, typically are used in a tension only lift. As soon as you start picking at an angle from there, you start decreasing the capacity of the insert. So these are what we call tension related. So you're going to be wanting to pick them straight up and setting them straight down. If you have to pull from an angle, you have to take that consideration of derating the capacity of the insert before you pour. And why is that? Well, most of us all know, most of the coil products that we all make are very good in tension. They're not very good in shear. Shear loads on a typical coil rod product is about only about 60% of that in tension. So when the bolt gets put into shear, the bolt will break prematurely and cause a failure. One of the things you have to also look at here, you see guys will attach a ferrule insert on, or excuse me, a NC threaded, boy, screw that up. They will put a coil insert on the end of the panel and then attach a bolt or a lift plate to it, putting it in shear. Well, concrete is great, but to actually achieve the strength, you have to have surface area and volume around it. So what's happening here is if you don't have shear plates or shear bars in here, you're going to pull that right straight out of the concrete. It just isn't going to happen. You just don't want to have that this type of an application. So we have the Swift lift system. Excuse me. The Swift lift system basically came to America in 1972. Dayton brought it in here from a company called Dayton. It's a non-welded hot forged anchor system. The anchors typically provide a 4-to-1 safety factor. Uh, Hardware is a 5-to-1 safety factor, available from 1 ton to 20 ton, safe working load available. More commonly referred to as dog bones. And you see the dog bones here with the two different, basically it has a head on the top and a head on the bottom, what we call the foot. And the foot is usually a little bit bigger diameter because it's going to be embedded in the concrete further. So you want to spread that shear cone out as much as you can. The head on top is actually geared so that it's set up so that it can handle the multiple pickups and releases with this product. So it's actually stronger. Now, the load rating for all these inserts, great idea, was they actually stamp it right on the top of the insert itself. So you know right away what you have. And the lifting hardware has the same numbers etched on them. So you know if you have a 4-ton lifting hardware, it'll work with a 4-ton insert. And this is one of the inserts that are actually predominantly used by the civil and structural group that we talked about earlier. And primarily because of the number of sizes that are available, the depth, to everything else, overall diameter, 4-ton, 8-ton, 20-ton. It is a very simple system to use. It uses a round recess void, which typically comes into place. So it gives you 360-degree rotation of your lifting hardware. And why is that important? Well, remember I said that those civil structural guys, they're making stuff that's funky shaped and everything is a little bit off a little bit. There's nothing, predominant. It's not a flat panel. It is going to be something that may need to be rotated, etc. Well, this is the insert you want to use for that. You also can get these inserts with magnetic bases if you're still using those forms that are magnetic plates at the shop. You can get a magnetic lifting plate already attached, or you can get one that will attach to the recess void. So we can do it either way. We can either have the recess void and the metal plate, or we can sell you the magnetic recess void with these. Now the fleet lift system. This has predominantly been designed for the architectural precast lifting systems. When you're looking at these are the guys doing tall panels. Mostly, almost everything you see them do is like structural. They do a lot, parking garages, uh, precast tilt, etc. Those type structures, warehouses, etc. So, and we actually had two different formations of this system. We had a stamp system that we started out with, and a lot of contractors still like the stamp system. But a little while later, we switched over to a new design of a forged unibody. So basically, this product was cast, so there's no welded plates to the insert at all. And these inserts kind of match up, basically what can be in an old design can be also be supplied in a new design. And new design also should have something coming back to the old design. They all both use the same recess members. And the recess members come in cast iron for those guys that are doing a lot of casting in parts of where they're going to steam cure a lot of the panels and they're going to do the inserts going to be in the same location all the time. They can weld it to their forms, or they can do it in urethane, which is probably the most common. And then we see the plastic version for those guys that have to do it in a one-off type situation. They are all held in place here with a wing nut and bolt that comes into place and threads into the back of the urethane recess void. And then the thumb screw just basically tightens down to hold it up tight against the form. We got a couple of different bales for lifting on these products here. We have our cable bale, our 1 ton, 1 to 3 tons, 4 to 6, and 8 to 10. We also have our standard bale, which is our T91. Our P91 is a standard bale, 1 to 3 tons, 4 to 6, and 8 to 12. So you'll see that one is the most common one we use. That 12-ton lifter is also the same one that we use for lifting tilt panels. How to resist shear loading, shear bar plate applications. You can actually, we talked about shear. If you had a coil threaded insert and put it on the edge of the panel, how are you going to stop that from just being pulled off? By putting a shear bar on it. You're basically spreading the load out. You can do that a couple of different ways. One with a shear bar, or two, put a shear plate with an insert with a shear plate already attached into it. And you can also get a shear plate and a supplementary shear plate on the top, which may be just a flat piece of steel stock, which actually enables you to actually flip the panel over and then flip it back up if you need to. The last system that we're going to talk about here is we've got our utility anchor system. Utility anchor system was designed primarily for those guys doing drop inlets, manholes, pipe, etc. And this insert here has no proprietary lift clutch requirements. You can lift with a clevis or you can lift with a Crosby hook. And both of these products here typically can be shown just right here, how they're actually engaged. The big thing you have to worry with both of these products is coming off at a more than a 45-degree angle because they don't recommend it. Primarily because of shear going onto the Crosby hook or the shackle. The anchors come in a variety of sizes. You're looking at everything from a panel thickness of 4 inches, and we can go all the way up to 12 inches. So we can pretty much accommodate anything that a general utility contractor was looking for with one of these inserts. We've also got recess voids, both available in what I'll call the light and medium duty. They're available in a 90-degree and a 45-degree. So in case you're going to be lifting at a 45, you can actually set your recess void at that. And we also have our heavy duty one, the big blue. It's 15 inches and it's fairly heavy. It's fairly stout, but that's only available in a 90-degree insert or recess void. For retaining wall, we've got a similar system to our utility anchor. The retaining wall anchor typically gets embedded in the concrete retaining blocks that actually are set up for restacking. They are designed for lifting and handled wall retaining blocks. Sometimes contractors will dry set these in, and then sometimes they will wet set them using a recess void. Sometimes they don't use the recess void and they'll just leave the hanger hanging out in the backside where they're going to backfill. And last but not least, we have our P110 wire rope lifting system. Typically, you'll see this on a lot of box culverts, drop inlets, a lot of utility work here that typically once the product is set in place, they'll come back in with a grinder and just grind this off flush with the surface. We have them available in up to from 1,600-pound capacity to a 20,000-pound capacity. Last but not least, we have our P77H for those guys doing double T anchors. These systems are available in 18 and 23 inch, so 8-ton and 10-ton. They come with a specific recess void that actually forms in here and what the shape of this system is, the great thing about it is it allows you to position your anchor within your double T. So you can actually turn it 90 degrees, you could turn it 180 degrees, 90 degrees, whatever you want to do, just so that you can actually accommodate how thin or thick your double T is. Resources. Well, as Heidi alluded earlier, we've got resources at DaytonSuperior.com. We got product information sheet, tech data sheets. We've got certificate of compliance record. We got our precast handbook, which is a great piece of literature to have available. Inside that handbook, you also have all of our lift charts. And actually, on the website themselves, they have all the current and up-to-date lift charts available, just in case something changes for over the years. The engineers have to have something to do, so they kind of throw them at, they retest product here to make sure we're still getting the highest quality that we can out to you.
We just had two engineers throw a tomato at you that's in the audience.
That's all right. I wouldn't throw anything bad at them. Because they do a hell of a job here. They make sure that the products you're getting will work for the price or the product that they say will hold. And so what they're doing is they're actually a quality control aspect of this whole thing. I guess I backpedaled enough there, didn't I? So contact information, you can get that on our website. Go to DaytonSuperior.com. Up at the top tab, you have contact information. You have who to contact. And go to the Dayton Superior side. Maps will drop down, pick your region of the country that you're in, and you can actually sort down to find out who your salesman is and who your precast salesman is for that region. It also gives you all their phone numbers too, so you can haunt them if you need to. So, and before, as Heidi alluded, if you're looking for training, here's the scan. Request a training class from either training@DaytonSuperior.com or scan the request up above. Types of offerings. We do lunch and learns, custom, AIA, engineer, and in-person and virtual classes. So sign up today if you need a class. Go to DaytonSuperior.com and search Training Tuesday if you're looking for this presentation or any of the other 140-ish that we have out online right now. So, well, this week, the reason we're talking precast is the precast show up in Indianapolis. Dayton Superior is there at booth 1147. Why don't you, if you're up in the Indianapolis area, take a stroll over to the convention, the Indianapolis Convention Center, and see us at booth 1147.
It's that QR code again in the bottom left. That goes to our training request form if you need it. So I'm not seeing anything, Chuck.
Okay.
Good time. So I'm sitting here hitting my watch like, Chuck, hurry up. And he did it. Good for you.
1 minute early.
1 minute early. We have time for a question. I'll remind you, Chuck already told you that these guys are all recorded and we put them on DaytonSuperior.com as well as YouTube. Everything kind of talks to each other and you can get to them all organized out on DaytonSuperior.com. So yeah, I don't see any questions. I think we're good for this week, and I want all of you guys and gals on the phone to have a fantastic Tuesday. Do you want them to have a fantastic Tuesday?
Have a fantastic Superior.
Oh, yeah, okay.
And everybody stay healthy.
That's right. So bye, guys. We'll see you next week.